Here is the Math 1111 Zoom meeting for October 15th. And this week we had assignments, week from 1012 to 1016. We're doing sections 3.3 and 3.4. Practice problems, these sections in section 3.3 and in 3.4, page 319, these sections of problems. Not for a grade again, but quiz 7 will be based on them, and quiz 7 will be on Friday again, due Sunday 10/18. And we did not assign WebAssign problems this week. I know that breaks your heart, but we are probably, the reason for that is that we are probably on the peak of difficulty of the class, 3.3 and 3.4. So we're going to show you a few example problems here. 3.3. Long division. I cannot really think of a section that drives students nuts more than this one in all the math I teach, from learning support all the way through calculus. So I'm going to try to keep it as concrete as I can, because you've got to remember your 4 words, and it works off of numbers. Off of numbers. And you probably haven't done a by hand long division problem since, my son's doing it now in 5th, 6th grade. So it may take a while, but it illustrates the 4 words you're going to need to know. All right, so we'll start with numbers. If I take 15 and divide it by 3, everybody can kind of do numbers in your head. You know I get 5. Okay, let's do it the long way. You take 15, you put it under this division sign, you put the 3 out here. And you are now supposed to think, okay, well, 3 doesn't go into 1, but 3 goes into 15 5 times. You then multiply that back, that will give you 15. And you subtract and you get 0. Now this illustrates the 4 words you need to know. The 4 words you need to know. This number here, dividend, dividend, divisor, quotient, remainder. This is an even division. The book will have you submit the homework based on these 4 words. Notice, quotient times divisor equals your dividend, with remainder 0. Equals 0. Another name for quotient is called answer. Another name for quotient, it is called the answer. Now, With remainder 0, it is the whole answer. If the remainder is not 0, with remainder 0, the quotient is the whole answer. If the remainder is not 0, the answer only starts with the quotient. All right, so that leaves us, we call this number 1. That leaves us with, say, number 2, to take 17 divided by 15. Now, again, you're probably good enough to do this in your head. 5 goes into 17 3 times. 5 times 3 is 15. That leaves up to 17 2/5 left over. And you can again multiply again to go backwards. 3 times your 5. 3 times 5, add the 2 gives you 17, and you're still dividing by 5. Okay, divide it out long way, long division into 17. Well, it doesn't go in evenly, so it goes in 3 times, multiply back, 15, subtract, and you get 2. Now, we could get decimals up here, but we're not going to play it that way. We're done. The answer is quotient, add remainder, divided by divisor. Take a look. So your quotient is 3. The remainder is 2, divided by the divisor of 5. Crush together. And you get your 3 2/5. Okay, I hope this is jogging a bell. Try formulas. If I take an x plus 3 and multiply by x minus 4, everybody know? I'll get x squared minus 4x, add 3x minus 12. X squared minus x in minus 12 equals x plus 3 and x minus 4. Trying to do something that looks familiar. But if you go back this way, you're factoring it, two numbers that multiply to -12, but add to -1. That'd be 3 minus 4 is your -1, and 3 times -4 is your -12. Now, undo. I'll pick x minus 4. So if I take x plus 3 and x minus 4 and divide by x minus 4, the other side, I'll have to take x squared minus x minus 12 and divide by x minus 4. You'll cancel here. So if I take this formula, this quadratic, and divide it by that factor, I've got to get this. This would be my quotient. Dividend, divisor. Remainder equals 0. Okay, so try it. Take x minus 4 and we divide into minus x minus 12. And you play it exactly the same way as you do with numbers. You always go this lead piece into this first piece. In other words, what times x would give me x squared? Well, it would be an x. I like to line up my terms. You multiply back. X squared minus 4x. X times x, x squared. X times negative 4, negative. Now here's the tricky part. Distribute. That sign has got to distribute. It doesn't come up with numbers. The lead piece always cancels. Negative x minus negative 4x will be a positive 3x. And I bring down my negative 12. That's sort of round one. This is a game with rounds. That's kind of round one. Now we're going to play round two. X times what is 3x? That would be a plus 3. Multiply back. 3x minus 12. Subtract again. Distribute. 3x. Oh, the lead piece always cancels. If it doesn't, you're screwing up. Negative 12 minus negative 12 will be 0. There is my remainder. Dividend, divisor, quotient, and notice quotient times divisor equals my dividend. Quotient is x plus 3, divisor x minus 4, dividend x squared minus x minus 12. I don't know if that proved anything to anybody or only to me. We'll try some homework. We will not mess with synthetic division. It only works with linear factors. Long division works every time, and that's the method I always use. All right, so try some homework problems. Homework, this is for 3-3. Page 309. Okay, I'll just show it to you. The kind of directions get a little. It says either synthetic or long. I always use long. Okay, and they want the answer in Q of x, add remainder divided by divisor. Okay. So they're giving you number 3, that P of x is 2x squared minus 5x minus 7. This is your dividend. The d of x is x minus 2. That's your divisor. Express answer, quotient. Express quotient. That's another word for answer. In the form Q of x, and that is for quotient, add R of x, that is remainder, divided by D of x, divisor. In plain English, you're taking x minus 2 and dividing into 2x squared and minus 7. That might go evenly with a remainder 0. If it does, then it goes evenly in your answer. This is your answer. Then in which case you just have the straight quotient. If your remainder is 0, you just have straight quotient. If you don't have a remainder, then you've got both of these pieces. So we're going to go x times what is 2x squared, and that would be a 2x. 2x times x is 2x squared. This have to match. If you don't, you're screwing up. And we're going to get a minus 4x. Subtract, put this in parentheses because it distributes. Lead piece always cancels. A negative 5x minus a negative 4x, that's add 4x, that'd be a negative x and minus 7. So x times what gives you a negative x would be a negative 1, which would give you a negative x and add a 2. Subtract this in parentheses. It's very repetitive. It's just that you got to really keep track of your signs. A negative, notice this matches both with negatives, so when you subtract, they cancel. And a negative 7 minus 2 is a negative 9. So my answer then, quotient add remainder divided by divisor. 2x minus 1 is my quotient. Add the remainder divided by divisor. Now, what this means is, it may look like gibberish, but basically what this means is for a check, you can get a common denominator. Your common denominator will be x minus 2, which is your divisor, and your top will equal your dividend. Let's show you how it works. You don't have to check all of these. You can use the back of the book, but basically you got to come back to a common denominator form, which is this on top divided by this. So in effect, you're getting, if you take 2x minus 2x minus 1 times your x minus 2, add negative 9, and you're all over x minus 2. See, in effect, you've put the x minus 2, if I can get it on the screen, x minus 2 under this, but you got to put it on top. Now we got to FOIL this, bring in the negative 9. It's got to come back to my 2x squared minus 5x minus 7. It's got to come back to this. So you're getting 2x squared minus 4x minus 1x, sorry, 2x, that's a 4x. No, 2x squared minus 4x minus 1x plus 2 minus 9, all divided by x minus 2. So that's 2x squared minus 5x minus 7, all over x minus 2. And that is your common denominator form. Basically right back to this. But your answer is you've split it apart in effect. And you had a remainder, so you've got quotient, add remainder, quotient, remainder divided by divisor. Put it back in common denominator form, and you come right back to this divided by this, right here. All right, some get longer than others. Why don't we try one like number 7? Your P of x, 2x to the 4th minus x cubed, add 9x squared. D of x, divisor, x squared, add 4. Divisor, dividend. X squared, add 4. I'm going to go 2x to the 4th minus x cubed, add 9x squared, plus 0x plus 0. I always fill in missing pieces with zeros. It's very tough to do blanks. It's very confusing. So if I was missing the x cubed, I'd have stuck a 0x cubed here. All right, again, x squared. You start the game by asking this piece times what would give me this piece. Apparently a 2x squared. 2x squared times x squared, 2x to the fourth. Multiply again by that, you'd get an 8x squared. Again, line up your pieces. You must line up the like terms, put them in parentheses, distribute your minus. Lead piece cancels. I'm going to bring down a negative x cubed. And a 9x squared minus an 8x squared will be positive x squared. I'll tack on the 0x plus 0. All right, x squared times what is a negative x cubed? Be a negative x. Negative x cubed minus 4x. Subtract. Lead pieces cancel. We're bringing down an x squared minus 0x squared. 0 minus negative 4x will be a positive 4x plus 0. All right, x squared times what is an x squared? Well, that's too easy. That's plus 1. So 1 times x squared is x squared, and 1 times 4 is a 4. Subtract. Bring down a 4x. 0 minus 4 is a negative 4. We're now done. Your power here is less than this. Notice on this line it was equal, so you can still keep going. It took 3 rounds of this game. Answer. Quotient. Add remainder divided by divisor. All right, just to give you some confidence or see if I'm an idiot, let's check this one with the back of the book. 3-3, number 7. Okay, let's see. I'll give you this one. Right, okay, 2x squared plus x plus minus x plus 1. 4 over x squared plus 4, number 7. Add 4x minus 4 over x squared. I don't know if I put them side by side. No, I can't really. Well, tough. Okay, so you put that in your brain, and number 7 is identical. All right. The rest of the sections are really similar. Again, if they give you a choice, oh boy, please don't do this to me. Okay, appears I lost my green. So let me see if I can get my camera back. All right, looks like I did. The rest of these are, they'll tell you synthetic division on some of them. You don't have to. I have my assignment in front of me. Yeah. This is just going so flaky. See if it'll resume it. I'm gonna have to do it again. Sorry about this. Okay. 63 and 65. Okay. This should get you through most of them. 15 to 27. Let's see, I'm sorry, 15 to 37. Again, I'd ignore, if you know synthetic division, help yourself. I don't teach it. You can do everything with long division. And then last two are like 63 and 65. This is kind of going backwards. The idea is, page 310, say 63, create, or it's a C, not a G, a polynomial of degree 3 with zeros 1 and 3. Okay. You have to use this factor theorem, page 308. Factor theorem. If, or it says, actually it says C is a 0 of P of X, if and only if X minus C is a factor P of X. All right, go back to the example we had. Didn't we have X plus 3, just so I don't have to use it now, X plus 3 minus 4, X squared minus X minus 12. These are the factors. Of P of X. If I set this to 0, not having a good day today. Set to 0. So my P of X equals 0. This is my P of X we're talking about. Square minus X minus 12 equals 0. You should remember you can factor this equals 0. And remember you switch your signs. X equals negative 3 and positive 4. These are the zeros. So basically, X equals 4 is a 0. So X minus 4 is a factor. That's what they're saying. You switch the sign to go on the factor. So in other words, X plus 3, X minus 4, if I use X equal 4, I'll get 0. X equal 4 right there. I'll get X plus 3, 4 minus 4, which equals 0. All right, but I also get on the other side, checking P of X, this 4 squared minus 4 minus 12 equals 0. 16 minus 4 minus 12 does indeed equal 0. If a start with P of X, it's kind of common sense. P of X, say, minus X minus 12. If a number, X equals 4, makes this 0, 4 squared minus 4 minus 12 does indeed equal 0. Then x squared minus x minus 12 has to have a factor, x minus 4. So 4 here makes this 0. And 4 here makes this 0. So you see what happens. If you've got a positive 0, you get an x minus 4. It also had add x was negative 3. The factor was x plus 3. Because this factored to x plus 3. The other factor was x plus 3. Okay, back to 63. The zeros, negative 1, 1, and 3. The factors are then x plus 1, x minus 1, and x minus 3. If these numbers are 0, they make the polynomial 0. They've got to have these factors. So negative 1 plus 1 is 0, 1 minus 1 is 0, 3 minus 3 is 0. Find the polynomial. The polynomial is x plus 1 and x minus 3. And we're going to multiply out. So p of x, all right, again, x plus 1, x minus 1, minus 3. I'll do them two at a time. X squared minus x plus x, maybe you do that in your head, minus 1. All right, so p of x, now foiling this out, you get x cubed minus 3x squared minus x, add 3. Polynomial of degree 3 with zeros, negative 1, 1, and 3. Check. Just to show it's not total hocus pocus. P of negative 1, we better get 0. Negative 1 cubed minus 3, negative 1 squared minus negative 1, and add 3. 1 to the third, negative 1. You get a 1 there and a negative 3. Positive 1, positive 3. You could add them all if you wanted to, but you can see the individually they cancel. Presto, there you get 0. All right, so that's an example of everything they're doing in 3.3. Let's go on to 3.4. Rational zeros. Okay. How do you find zeros? Page 312, and you can see the gibberish here. I'm going to write down the gibberish, then I'll stick in some numbers trying to make it concrete. A-N, x to the n, blah, blah, blah. And then you really have to pay attention to the lead. This is called the lead. and the end plus a 0. Okay. P is a factor of a 0, the end. Q, factor of an, the lead. You can form a list of all possible zeros is P divided by Q, which are factors of the end number divided by factors of the lead number. Okay, I realize it's probably it seems like complete gibberish. So let me try example 1, their first example first. 1. Okay, find the rational zeros of, this is off page 312, P of x, x cubed minus 3x, add 2. Okay, here's our list, all possible zeros. They call it P divided by Q, and you take factors of 2, that's the end, over factors of 1, which is the lead. If you don't see a number on the lead, then you assume it's a 1. Well, the factors of 2, they always start and work their way up the number line. Plus minus 1, plus minus 2. Those are the only numbers that will multiply to 2, and they can be positive or negative. Factors of 1 is really easy. That's just plus or minus 1. The only possible numbers that multiply to 1. You can spread this out. You can take plus minus 1 divided by plus minus 1, comma, plus minus 2. Take each number on top divided by the bottom individually, divided by plus minus 1. All right, well, 1 divided by 1 is just 1, and 2 divided by 1 is just 2. There are 4 numbers. I can't believe I didn't knock it off. 4 possible zeros. One, -1, 2, and -2. Only way to proceed is to literally substitute them in and see which give you 0. All right. P of x, x cubed minus 3x, add 2. Try the first one. X is 1. What is literally P of 1? Minus 3 times 1 and add 2. Looks like you're getting 1 minus 3, add 2. -2, add 2, which gives you 0. X equals 1 is 0. It will have P of x. The point is, x cubed, and it doesn't really ask you to factor this one, we'll have a factor of x minus 1. P of x has a factor x minus 1. So 1 gives me 0 plugged in this side, and 1 minus 1 gives me 0 this side. We're going to use this to factor these things, although it didn't ask for that here, but that's the whole point of this. It will in the homework. All right, check x equal negative 1. Negative 1 is equal to negative 1 cubed minus 3 times negative 1 and add 2, which will give you negative 1, add 3, add 2. Positive 2 add 2 is positive 4. X equals negative 1, not a factor. Just ignore it. All right, I guess we'll try x equals 2. P of 2. 2 cubed minus 3 times 2, add 2. 8 minus 6, add 2, also gives me 2 plus 2, which is 4. Ignore it. Number 4, x equals negative 2. Negative 2 cubed minus 3 times negative 2, add 2. Add 6, add 2, which is negative 2, add 2, which is 0. Is a 0. Now I know two factors. I know x cubed minus 3x add 2 as a factor of x minus 1 and x plus 2. As negative 2 plugged into it gives 0. And therefore negative 2 plus 2 here would give us 0. The real rest of the chapter, they've got to see, this will only give you a quadratic. So the rest of the chapter is going to be, how do I find the missing factor? Long division. But they're not asking for that here. Okay. Let's try some homework problems here. Assignment 5 to 9. Page 319, this is 3.4. Let's say it's problem 5, P of x. X cubed minus 4x squared, add 3. List possible rational zeros. P over Q, factors of 3, factors of 1. That would be plus minus 1 plus minus 3 over plus minus 1. You can spread this out, plus minus 1 over plus minus 1, comma, plus minus 3 over plus minus 1, which makes just plus minus 1, plus minus 3. Very similar to the last problem, just 4 possible zeros. Try a little more complicated one. Try one like number 10. Give you a u of x, 12x to the 5th, 6x cubed, x minus 8. List. Didn't say to check which ones are actually zeros. All possible rational zeros. All right, so the P over Q for here would be factors of 8 over factors of 12. All right, you just go up the number line. Plus minus 1, 2 works. 3, 4 works. And when you hit half of 1, you're done. You can jump to the end. 12 plus minus 1, 2 works. 3 works. 4 works. 6 works. And now I'm halfway to 12, so finish with 12. This could be quite a long list. You match each number on top to each one on bottom. One on top to each one on bottom. Ignore repeats. So I'll have 1 over 1. I'll write it out really painfully. You can 1 over 1, 1 over 2, 1 over 3, 1 over 4, 1 over 6, 1 over 12, comma, plus minus 2 over 1, plus minus, now 2 over 2 would be the same as 1. Maybe I'll write it down just to show you, then cross through them. And then plus minus 2 over 3, plus minus 2 over 4, plus minus 2 over 6, plus minus 2 over 12. I'll write it all out painfully, and then we'll cross through everything, boil the list down. Plus minus 4 over 1, plus minus 4 over 2, 4 over 3, plus minus 4 over 4, plus minus 4 over 6, 4 over 12. Last row, plus minus 8 over 1, 8 over 2. I'm off the screen. Plus minus 8 over 3, plus minus 8 over 4, 8 over 6, plus minus 8 over 12. Heck of a list. All right, I'll go through. The first row is probably going to be all alike. You're going to have plus minus 1, a half, third, fourth, lost my plus minus a fourth, 6 plus minus 1, 12. Okay, second row, 2 is not on here, so that's in. 2 over 2 is 1. 2/3 is in. 2 over 4 is a half. 2 over 6 a third. And 2 over 12 is 1/6. Plus minus 4. 4 over 2 is 2. 4 over 3, that's in. 4 over 4 is 1. 4 over 6 is 2/3. 4 over 12 is 1/3. Plus minus 8. 8 halves is 4. 8/3 is in. 8/4 is 2. 8/6 is 4/3, and 8/12, I believe, is 2/3. That boils the list down to that. Now, it did say don't check which are possible zeros. And can you tell? Long way. Must sub in to P of X equals, it was X, 12X to the 6X cubed minus 2X and minus 8. All right, I'm going to pretend they didn't tell me that. I'm going to show you how to shorten it up. See which gives 0. We'll be here a long time. Short way. Use TI-84. Table mode. Enter P of X in your Y equals menu. I have 12X raised to the 5th. Add 6X raised to the 3rd. Minus 2X minus 8. All right, we're not going to graph it. Not get anything. We're going to have the calculator do it for us. Okay, that's step 1, or step 1 here. Enter the, just like you would graph it, but we're not going to graph it. So I've got the formula in. I'm aiming over here to use this table, but make a stop at table set. That's second F2, second window. Make sure everything's set on auto. Set your table set. Second window on auto. Then step 3, table. Second graph. Second graph. The calculator is plugging these X values into that Y1. Remember, Y1 is this. It knows Y1 is this. It is automatically plugging these X values into these Y1s. And what am I looking for? Zeros. X values that give me out 0. Can you kind of tell coming forward, getting bigger and bigger and bigger? In fact, now I'm into scientific notation. 712,936, and it jumped to 1.21 times 10 to the 6. I'm just getting bigger. I'm not going to get a 0 going this direction. So you can go back up the list. All right. And to be honest, I picked a bad example. I'm not getting any zeros. No integer zeros here. No integer zeros. Wish there hadn't been one. But at least it shows you the steps, and I'll do a couple more homework examples with these. So go back to table set. Second graph. Put on ask mode. The independent. It's spelled A-N-D-P-N-T. They shortened it up. Set this to ask mode. So you come down, put it on ask. Now when you hit second table, it's asking for the x and it'll plug in. I don't have to plug in any integers. I can start with 1/2. I'll go x equals 1/2 p of x. I hope I find one. Sometimes you don't. 1/2. Nope. Negative 7.875. No. Okay. Negative 1/2. Negative, you can use negative 0.5 or negative 1/2. Negative 8.125. No. All right, so I'm working my way up the list. So I've just done positive 1/2, negative 1/2. I'm going to do 1/3, negative 1/3. So x equals 1/3. 1 divided by 3. Nope. Negative 1 divided by 3. Nope. 1/4. Hope I hit 1. Divided by 4. Nope. All right, so 1/6 and then 1/12. 6. Nope. 1 divided by 12. Nope. Forgot to do the negatives of these. Negative 1 divided by 6. Nope. And negative 1 divided by 12. Nope. May have hit a bad example. If I ever hit 0, then I've got a 0 and I've got a factor. All right, looks like I've got 3 more to check. 2/3. 2 divided by 3. Nope. Negative 2 divided by 3. Nope. I'm wanting to hit 0. Watch me have picked a bad example to use. 4 divided by 3. Negative 4 divided by 3. Nope. 8 divided by 3. Negative 8 divided by 3. Okay, I picked a bad example. So none of them gave me 0. There's other things you got to do that's beyond us. I should have picked one that had a 0. Actually, no zeros off the list on this one. List. Okay, that gets a lot more complicated. But let's try some homework, and there'll be zeros on the homework. Let's jump to number 11. Well, you can see the zeros off the graph on 11. Maybe I'll show that one. 319. P of x, 5x to the third minus x squared minus 5x add 1. And they're giving you a graph. It's coming up through negative 2. Peaking, going down through 1. It's coming down through here. 1's over here. And going, then going up through 1. That's 1. That's at negative 2. Actually, that's at negative 1 if you look at the scale. It's misleading. Every tick mark's a half. So there are 2 divisions over. That's 1. So that's a negative 1/2. That'd be negative 1. Okay, it says list all possible rational zeros. P over Q would be factors of 1 over factors of 5 plus minus 1 over plus minus 1 and plus minus 5. Factors of the end over factors of the lead. That would give you plus minus 1 over 1 plus minus 1 over 5. All right, let me show you again on the calculator what I'm talking about. You would enter off the calculator. You would enter 5x to the third, 5x to the third, minus x squared, minus 5x, add 1. Back to table set, auto, go to table. Okay, way on the negative side, if I keep going more negative, I'm just getting bigger and bigger numbers. No way I'm going to get to 0. Come down the list. Aha, nirvana. X equals -1 is a 0. Is a 0. You can double check it if you want. You'd have 5 times -1 cubed minus -1 squared times -1 and add 1. -5 minus 1, add 5, add 1. You can see them individually cancel. Sure enough, 0. All right, you can also see x equals 1 is a 0. X equals 1 is a 0. I won't check it in. And you can see that off the graph. Can see this off the graph. But you also got a third one. Looks like it positive. There's a third one. Third one. X equals 1/5. Well, I could plug x equals 1/5 into that. Be a little hard punch. Don't have to. Go back to table set. Put it on ask. And go back to table. And put in 1/5. And I get 0. Sure enough, is a 0. The last one, just for completeness, was -1/5. You can kind of tell that won't be a 0, but I'll use it -1/5. And no, I don't get 0. So it's not a 0. In fact, it's one, but it's just short of the peak here, just below the peak. Peak probably 2. Okay. So from the graph, determine which of the possible rations actually turn out to be zeros. That would be -1, x equals 1, and x equals 1/5. You can check from the graph and also from the calculator. Let's see if we can get, I know we're getting long, but let's see if we can get one more in. Try 15. 15. There's 2 more sections. We'll try this section and the 29 section, and write the polynomial in factored form. Okay, so this is the full problem. Find zeros, write in factored form. P of x plus 2x squared minus 13x, add 10. Okay, list of all possible zeros. You need candidates. So it didn't tell me to make this list, but this is where my numbers come from. You see, if 2 is a factor, if 2 is a 0, I just made 2 up. X minus 2 is a factor. Well, where does a 2 come from, or where does the numbers come from? They come from this list. Okay, I just made this up. Just trying an example. That's why you have to start with this list. Made this up. So you take factors of 10 over factors of 1. 1, 2, 5, 10, and on paper, over plus minus 1. Well, when I take each of these numbers divided by 1, it doesn't change. So you're going to get plus minus 1, 2, 5, and 10, because dividing them by 1 doesn't change. We're only getting whole number zeros, possible zeros. Now, again, I could individually, for a long way, P of 1 cubed, add 2, 1 squared, minus 13 times 1, add 10. 1, add 2, minus 13, add 10. 3 minus 30, negative 10. Hit one, hit the first one. This is equal to 0. X equals 1 is 0. X minus 1 is a factor. All right, but you can see I'm going to be here a long while doing this. So we'll jump to TI 84. Clear? X to the third, X squared minus 13x, add 10. All right, am I set on auto? No. Auto. For whole numbers, you want to be on auto. It only automatically plugs in whole numbers. If you got fractions, you got to manually put those in. All right, so let's check out the 1. Sure enough, 1 is a 0. 2 is a 0. X equals 2 is a 0. X minus 2 is a factor. Do I get anything going up the list? Yeah, I do. X equals negative 5 is a 0. X add 5 is a factor. There should be 3 factors. That should be 3 zeros. It's a cubic, so that highest power gives you the number. And sure enough, I'm done. So, x cubed, 2x squared minus 13x, add 10 is equal to x minus 1, x minus 2, and x plus 5. I can plug negative 5 in here, get 0. So negative 5 here, add 5, I get 0. Okay, so it's starting off pretty straightforward. They can get a little nastier further into the section. Should be able to foil this back and get to this. I don't know if you all want to take time watch me to do that. You can check the back of the book. Let's try, goes through, I think I went through 27. All right, let's see. And then last section was 29 down to 43. And write it in factored form. All right, why don't we take 43, I remember, is a big project. Why don't we try something a little nastier? 35 maybe. We'll make this our last one. I know we're getting long. All right, same idea. P of x, 4x cubed minus 7x, add 3. And find all zeros and factor. All right, the P over Q, and we'll speed this up a little bit. P plus minus 1 plus minus 3 over plus minus 1 plus minus 2 plus minus 4. So you're looking at plus minus 1 over 1, 1 over 2, 1 over 4, plus minus 3 over 1 is 3, plus minus 3 halves, plus minus 3 fourths. List of all possible zeros. That is the list, all possible zeros. Use TI-84, table mode, to find actual zeros. Uh, 4x to the third minus 7x, add 3. All right, am I set on auto? I am, so table. All right, I guess I like to check each end first, but you see I'm getting bigger and bigger. I'm going to get nothing that direction. So again, I'm looking, if you can see this, I'm looking for zeros. 0, I hit 1, x equals 1. A 0, x minus 1 is a factor. And that's the only thing I'm going to find off this mode. That's the only one. So there should be 3. Should, I'll write it down here. Should 3. All right, let's check the fractions. In ask mode. Table set. Ask. Oh, oops. Table. All right, 1/2. Yes. 1/2 is a 0. X minus 1/2 is a factor. Negative 0.5. No. 1/4. See if there's any others. Negative 1/4. No. 3 was checked on the other. Okay, 3/2. No. Negative 3/2. Yes. Negative 3/2. Factor. Okay, how about 3/4? Nope. Of course, I guess there's 3. I guess when I hit 3, I'd know to quit looking. Power 3, so I guess checking 3/4 was, had a brain fart there. Okay. Factors. This means 4x cubed minus 7x add 3 has factors of x minus 1, x minus 1/2, and x add 3/2. X add 3/2. I'm sorry, God, I'm screwing this. X equals negative 3/2 is a 0. X add 3/2 is the factor. Now, this is perfectly acceptable, but not the answer in the back of the book. Not answer back of book. Show you. Three, four, make this the last thing I do because we're real long. This was 3, 4, 35. Three, four, this was 35. Book answer. Negative 3 halves, 1 half, and 1, zeros. All right. Their P of X looks like 2x add 3 and 2x minus 1. Show you. There's the if you do that, fade it out there, and then their answer looks like this. Okay, here's what they're doing. I'll rewrite it down here. My answer, P of X, I'm getting X minus 1, X minus a half, X add 3 halves. Okay. They are using common denominator form. So if I form a common denominator, put a 2 on here for a common denominator, if I do it to the bottom, I have to do it to the top. Same thing here, put a common denominator there with 2 there and put a 2 up top. Now that's giving you X minus 1, 2X minus 1 all over 2, and 2X add 3 all over 2. Now, why are they are now ignoring those 2's because you only care about zeros. And if you see, so X equals negative a half, you'd have 2 times negative a half. It's 1, all divided by 2. It was X is 1 half. I'm sorry, it was X was 1 half. 1 half, you get 1 minus 1 over 2, which is 0 over 2. So they're ignoring that, and they're just using the tops and creating the polynomial just off the tops. You can see negative 3 halves here. 2 times negative 3 halves, add 3. Give you negative 3, add 3, because the 2's cancel, which is 0. You don't have to do that. You can use this form. I'm just trying to explain how the book gets what they get. They form a common denominator and then just drop the denominators. That's an example of pretty much everything we've asked for. I've left off a lot of stuff like upper and lower bounds, Descartes' rule of signs. Don't thank me all at once. That's the basics of what we're asking for. This has gone very long. If anybody ever watched this, I really appreciate you hanging through till the end. We'll try to get this recorded, posted to YouTube, and distributed out. There's a lot of stuff this week, and it's pretty difficult material. So if you need more questions or if you have more questions, go ahead and please email me. Otherwise, we'll end the Zoom meeting, and we will try to get this distributed out.